this project, from the very beginning, the early concepting of this particular bridge, we chose a standard bridge, a 3-span bridge. We've got thousands of these types of bridges across the country. So the technology, the lessons learned on this project will be able to apply throughout our system.
The unique thing about this bridge, as I said, the construction duration is only 2 weeks from the time that they close the road to traffic until they have a completely new bridge in place and the road reopened. If this bridge was constructed kind of the conventional way, the way we've always done bridges, it would take 4 to 6 months.
We need to broaden our viewpoint and our analysis of what costs matter when we're thinking about how much we ought to spend. When you do a construction project faster, it almost always will cost more, but those may very well be dollars that are well spent if you're really stepping back and doing a thorough economic impact analysis of what's happening.
The users of the highway are paying more money for each minute or each hour that they are delayed in their trip. They're consuming gasoline and diesel fuel. The opportunity cost for the time lost is money lost to them. So overall, this short closure will probably cost far less money in total than the longer closure.
Sharp 2 brings forward innovation, and we're really looking for states to be willing to be innovative, and we think it's the right thing in this time.
Sharp 2 is really important because it's another major national initiative for these needed technologies. In renewal, we are facing an aging infrastructure. Our resources are really challenging as far as people, as far as money, and as far as needs. And Sharp 2 can really help us with a lot of the technologies that we need to implement in order to make the best use of the money that we have available, in order to make sure that we're following the best practices, the best engineering decisions that we can.
Sharp 2 program will do the research, do that homework up front, so a state can pretty quickly take what they've done and actually implement it in the field. Contractors, the unknown means a higher bid that you'll probably get. So with Sharp trying to do these demonstration projects, we'll get the information out there of how they work, get some of the kinks out, and give that comfort level to states to move forward.
There's always some risk of being first, being on the leading edge and trying something. And there's a learning curve in there that you have to kind of shake it out a little bit as you go through trying a new technology or a new process. So whoever goes first takes on a little bit more risk in doing that. We think when that leader is working side by side with the Federal Highway Administration, we can bring some extra technical expertise to that state that they might not have. It makes it easier maybe for that leading state to take that first step and say, we'll be first, we'll try it. And that's a really critical part of something like Sharp 2, is having a state or a few states that are willing to say, we'll go first.
A lot of people have ideas, but how do you know if they're going to work or not going to work? You learn in your failures as well as your successes, and so somebody needs to try it. This research takes a lot of ideas, cumulative needs of people, the industry across the country, and says, let's look at trying it. So it's information that's gleaned, that's a priority information, and then the implementation can go that much further to benefit a lot of people.
If we're calculating the impact of travel delay and what that means to the overall economy, and then we're putting that up against the cost of research and innovation, we're going to find that research and innovation is very cheap indeed.
Once you standardize the processes, the price comes way down. Once you learn how to build bridge elements, precast bridge elements, so that they can be moved by standard equipment on a highway project, then again, the cost comes down again. The goal of the Sharp 2 project, the RO4 project, is simply to make accelerated bridge construction an everyday process.
One of the values of this particular project is that it's not particularly exotic. It's common structural elements, materials, But these are the kind of products, if this technology is implemented a little more broadly, that contractors can be comfortable bidding on this. Agencies will be comfortable designing these kind of projects and looking for, not just wait for the right application to come along, but actually looking for applications where this might be repeated time and again, because that's where you'll get your savings.
Parts of it are real unique. I'd say 85–90% of it is just another bridge. That's the way we approached it. Yeah, it's in pieces. It's precast. We've done precast before. We'd set precast beams all the time. It was a whole different set of challenges. But as far as building the bridge and the way we decided to do it, building it on site, on false work, was probably the most unique thing that we did. But I'd say 85–90% of it is just a bridge. It's like lots of others we've built, but it's in 18 pieces in the superstructure, and then 8 pieces down below. 2 abutments, 2 pier caps, 4 columns, and then the drilled shafts it sits on.
From the very beginning, some of the design decisions that were made, we wanted to make sure that our local contractors were going to be able to build a bridge like this one. So that helped us decide what the superstructure was going to look like and several of the other design decisions. I think that's very important because we don't want to do research that's a one-of. I'm not really interested in looking at something that we're just going to try once. Why would we put money, time, and effort and expertise into that if we're not looking for the long haul with these opportunities?
We can't afford to let our roadways be incapacitated because of construction projects. And so the faster we can go, it's clearly valuable. When it really matters, we put very big incentive and disincentive clauses into our construction contracts, and there's no question when we do that, we're likely to pay more money, but it is clear that it is worth paying that money to get the contract finished and wrapped up and get the contractor off the roadway sooner.
What you're going to see is more and more states moving to new techniques, faster techniques. I think the public's going to demand it. And you're going to have to be able to balance that public need with the funding that you have and the resources that you have.
This project and this kind of technology can be used, as it proves itself, throughout the country to rapidly replace bridges and structures in very critical positions and help provide the economic commerce, the opportunity for transportation to exist and continue along these routes, whether it's locally or even regionally.
The 23 years I've worked with the DOT, it's been interesting. We all look at projects like this, or really even standard projects, as these are our projects. Everybody has ownership for that, and it's always like that. The people that live in this area that use this bridge, it's their bridge. And so I think it's very satisfying. Everybody that has worked on this project from all the agencies, from all the levels within the DOT, do consider this project their project, our project, and very good decisions have been made on this project, and it is a successful project, and it's just a testimony, I think, to the way that we want to work together and the way that we want to serve the public.